All right, we're going to continue on with our trig. What we're going to do today is a bit difficult, so we are going to practice again later on in the week. So the top of the page has that chart up there, and there's nothing really in it. This is what you're going to put in it. We're going to do, on the left side, you're going to remember SOHCAHTOA, right? So in SOHCAHTOA, sine of theta is the opposite over the hypotenuse. Cosine of theta is adjacent over hypotenuse. And then tangent of theta is opposite over adjacent, right? We did that a whole bunch of times a few weeks ago. SOHCAHTOA. Now, we can also do that with the reciprocal functions. There's not a new phrase that you're going to learn. You're just going to take the reciprocal of these. So if the sine of theta is opposite over hypotenuse, the reciprocal of sine is cosecant. And if sine is opposite over hypotenuse, that means that cosecant is hypotenuse over opposite. You're just going to flip it. The reciprocal of cosine is secant. So if the cosine of theta is adjacent over hypotenuse, that means that the secant is hypotenuse over adjacent. That's an H on top. Reciprocal of tangent is cotangent. And if tangent is opposite over adjacent, cotangent is adjacent over opposite. You're just going to flip it. That's literally all you're doing. So if you look at this example below, I give you all of the sides of a right triangle, right? This is a right triangle, right angle in here. And I'm asking about angle theta. So sine, let's go through and just make sure we're good on what's opposite, what's adjacent, what's hypotenuse again. So the hypotenuse is across from the right angle. So across from the right angle is the square root of 13. The opposite is across from the actual angle itself, right? So that's going to be the 2. And then the one that's left over is the one that's right next to, but not the hypotenuse. It's right next to theta, our angle, which is 3. So in this example, opposite is 2, hypotenuse is the square root of 13, and adjacent is 3. So now when we go through to do this, sine of theta, sine is opposite, which is 2, over hypotenuse, the square root of 13. So now, because you can do that, you can do the cosecant of theta. All you have to do is flip that fraction. So 2 divided by the square root of 13 is the square root of 13 divided by 2. That's the reciprocal of it. Let's do cosine and secant. Cosine, I'll do in blue again. Cosine is adjacent over hypotenuse. Adjacent to that angle is 3. Divided by the hypotenuse is the square root of 13. So cosine of theta is 3 divided by the square root of 13 in this triangle, which means that secant is the square root of 13 divided by 3. And then lastly, tangent. Tangent is opposite over adjacent. Opposite in our triangle is 2. Divided by adjacent is 3, which means the cotangent is 3 over 2. Okay? Now the other thing I want to talk about is rationalizing a denominator. Whenever you have a square root in the bottom of a fraction, in the denominator of a fraction, you have to rationalize it. You have to get rid of that radical in the bottom. And the way that you do so is by multiplying it by itself. So you only have to do that for sine and cosine. You see how sine and cosine, they both have the square root of 13 in the bottom? Nothing else does? So you have to clean that up. So you multiply the top and the bottom by the square root of 13. 2 times the square root of 13 is 2 square root 13 divided by the square root of 13 times the square root of 13 is 13. Okay? So sine of theta, it is 2 divided by the square root of 13, but more appropriately is 2 times the square root of 13 divided by 13. You don't want to see a radical in the bottom of a fraction, okay? We're going to do the same thing for cosine. So I have the square root of 13 in the bottom, so I'm going to get rid of it by multiplying it by itself. What I do to the bottom of a fraction, I also have to do to the top. 3 times the square root of 13 is 3 square root 13 divided by the square root of 13 times the square root of 13 is 13. Okay? So you're going to need all of that to do what we're actually doing today. Okay? What we're doing today, I am going to give you one trig function. So for example, I'm going to tell you what sine is, and then you're going to have to tell me then what's cosine, what's tangent, what's cosecant, secant, and cotangent. Okay? The hardest part is in these first 3 steps. Okay? So it's a little confusing, so I wrote them out for you, and I'm going to just go through one at a time really quick, and then I'll explain more when we go through it. So first you're going to draw the angle. Then you're going to create a right triangle with the reference angle. Then you're going to label the sides of the right triangle. Make sure you put any negatives, but your hypotenuse is always going to be positive. Step 4, use Pythagorean theorem to find the missing side, right? A squared plus b squared equals c squared. That's Pythagorean theorem. And then last, you're going to find all the trig functions and rationalize the denominator if necessary. So that last step is what you just did. Okay, so I know that doesn't really make any sense until you actually apply it. So let's go through this first example, okay? Example 1, if the sine of theta is negative 3 over 5 and theta terminates in quadrant 4, find cosine, tangent, cosecant, secant, and cotangent. Okay, so I give you 1, I give you sine, and I ask you for the remaining 5. Okay, so first step, draw the angle. So we're in quadrant 4, so I'm going to kind of zoom in on quadrant 4, right? So now I'm going to draw an angle in quadrant 4, so I'm just going to come straight out. Doesn't really matter where, any angle that you want, okay, in quadrant 4. So you just go straight out with your angle. Step 2, create a right triangle with your reference angle. So a right triangle with the reference angle. The reference angle is the fastest way for you to get to the x-axis. So that would be me going straight up. So now this is my triangle. You're going to draw theta. Right, this is your right angle. That's why we're able to do this. That's your right angle. Theta is directly next to the origin, but it's in the triangle. That's theta. Okay? So now, sine of theta is negative 3 over 5. Let's ignore the negative for a second. So sine of theta is 3 over 5. So the sine of theta is opposite over hypotenuse. So opposite the angle, opposite theta, right here, this is going to be 3. The hypotenuse, that's going to be 5. So for now, we can call this x. So what are we up to? Your fourth step is to use Pythagorean theorem to find the missing side. So Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So c has to be 5. A and b doesn't matter if you switch it up. So we have x squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. X squared equals 16. You take the square root of 16. That means that x is equal to 4. So instead of x, I'm going to come up here and erase this. X is really 4. Okay, now there was something that I kind of skipped over in step 3 about the negatives. So if you look at your triangle, right, this is the origin. If you move 4 to the right, that's positive 4. And if you move 3 down, that's negative 3. That's why it's negative 3 over 5. Okay, again, go from the origin. So the origin here, if you go to the right, then 4 is positive, and you're going down, so 3 is negative. Okay? And then from here, this becomes exactly like what we did in that first example that I showed you. So what I want you to do is I want you to write sine of theta, cosine theta, tangent theta, right on top of each other. And then to the right, I want you to write the reciprocals, kind of like how that table is set up at the top. So then you have cosecant theta, secant theta, cotangent theta. Okay, so sine of theta, sine is opposite over hypotenuse. It's given to us in the question though, right? Opposite is -3 divided by the hypotenuse is 5, which means cosecant is the reciprocal of that, -5/3. I get this question all the time. If you want to write 5 over -3, I don't care. I don't care where you put the negative, top or bottom, as long as it's there. Cosine is adjacent over hypotenuse. So adjacent to angle theta is 4 divided by the hypotenuse is 5, which means the secant is 5/4. Now that's positive. Remember, we're in quadrant 4, so cosine and secant should be positive. And then tangent is opposite over adjacent, which means cotangent is adjacent over opposite. Okay? So they're all just flipped of each other. And then you also just want to make sure that any denominators are rationalized. There aren't any square roots in this question at all, so you don't have to do that last step like we did before with the square root of 13 thing. Okay? And number 2. If the tangent of theta is the square root of 5/2 and theta terminates in quadrant 3, find everything else. So we're in quadrant 3, so I'm going to zoom in a little bit on quadrant 3. I draw a random angle going out, right from the origin, random angle going out, and I go straight to the x-axis. Now, this is my right angle. Theta is inside the triangle, and it's right next to the origin, so it's going to be right here. That's theta. Okay? Tangent is opposite over adjacent. So opposite theta is right here, this side right here. That's the square root of 5. This side here, that's across from the right angle, so that's the hypotenuse. This side here is going to be 2. That's your adjacent side. We'll deal with the negatives in a second. Let's find the missing side using Pythagorean theorem. So again, Pythagorean theorem, a squared plus b squared equals c squared. This side is your x. X happens to be your hypotenuse, so that has to go in for c. So it's different than before. So a, we can make the square root of 5 squared plus 2 squared. Doesn't matter if you flip them, right? The square root of 5 squared is 5, right? The square root and the square cancel out. Plus 2 squared is 4 equals x squared. 9 equals x squared, so x is equal to 3. So I'm going to erase my x value because x is 3. I know that now. Okay, now we'll talk about the negatives. So your hypotenuse is always positive, right? So 3 is positive. Now if I am going, this is the origin, right? If I am going to the left 2, it's a -2. And if I'm going down square root of 5, it's negative square root of 5, right? That's just how the quadrants work. You're going left, so it's a -x, and down, so a -y. Okay. And then again, that's the hard part, really. So now you're going to write sine, cosine, tangent, which tangent you already know is the square root of 5/2. 2, there we go. And then you're going to write the cosecant, secant, and cotangent. So you can do the cotangent right away too, right? The cotangent is 2 divided by the square root of 5. So we're going to have to clean that up in a second, right? No radicals in the denominator. So the reason why in tangent and cotangent you don't have negative square root 5 divided by negative 2 is because a negative divided by a negative is a positive. So it cleans up to be this anyway. If you put a negative over a negative, you're technically not wrong. It's just that they cancel each other out. So now sine. Sine is opposite, which is negative square root 5, over hypotenuse, which is 3. Cosine is adjacent, negative 2, over hypotenuse, which is 3. Tangent, again, opposite is negative square root 5, over adjacent is negative 2. The negatives canceled out. So if you did that separately or if you just copied it from the question, it doesn't really matter. So let's do the reciprocals. Cosecant, you flip them, so negative 3 over the square root of 5. Secant, you flip cosine, is negative 3 over 2. Cotangent we already have. So now lastly, I have to get rid of any square roots in the bottom. So cosecant and cotangent need a little bit of work. To get rid of the square root of 5 in the bottom, I multiply the tops and the bottoms of these fractions by the square root of 5. Negative 3 times the square root of 5 is negative 3 square root 5. Divided by the square root of 5 times the square root of 5 is 5. Cosecant is good now. Cotangent, you're going to multiply the top and the bottom by the square root of 5. So 2 times the square root of 5 is 2 square root 5. Divided by the square root of 5 times the square root of 5 is 5. And that's it. Okay, so we're going to practice again later on in the week. Tomorrow you're going to have a few questions up for you to practice with as well. Have a great day.